All right. So hello, everybody, and welcome to yet another GBO Science Lunch Talk. Today, we have a pretty awesome talk, in my personal opinion, as I've gotten the opportunity to hear similar discussions before. Today, we have Dr. Kevin Cooke, who is from the University of Kansas and is actually a friend of mine from all the way back from grad school. So I have the pleasure of introducing him today, where he will be talking about the early days of the race to the moon leading up to the Apollo 11 moon landing. So everybody, if you could hold your questions till the end of the talk or put them in the chat, and we will get to them once the main talk is over. But with that, I'd like to hand it over to Kevin to tell us about what went down about 52 years ago.
Thank you very much for the great introduction, Jesse. It's a pleasure to be here, and it's nice to see many new faces that are interested in this content. So I am Dr. Kevin Cooke, a postdoc at the University of Kansas. And while I traditionally work on the stellar mass growth of galaxies and the role of AGN in galaxy evolution, I also have a strong interest and focus in spaceflight history on the side. And this comes from working at the US Space and Rocket Center prior to starting my PhD in grad school. And so I've always had this passion for sharing the story of the politics and partnerships of the space race. And this will actually continue into the future steps of my career as a AAAS Science and Technology Policy Fellow at the NSF starting this fall. But today, we're talking about some of the political background and the achievements of America's race to the moon. And this story gets started in the aftermath of World War II, where many of the power blocks of the world, the US and its allies and the USSR and its allies, were working to advance the technology of rocketry after the technology's advancements in the hands of Nazi Germany with the V2 during World War II. And it was during this time of development in the 1950s that the international community also wanted to highlight the peaceful use of the technologies developed during the 20th century. And so, inspired by Austrian explorer Karl Weyprecht's first international polar year in 1881, the International Council of Scientific Unions decided to plan an international geophysical year. Not just a year focused on the exploration of Earth's poles, but an exploration of pretty much all of geology and geophysics, with the added objective of understanding the interplay between the Earth and the solar wind surrounding it. And many countries signed up to be part of this International Geophysical Year, the IGY. You can see some stamps from the various member countries like the US and the Soviet Union. And the role of each country was under contemplation as to how best to contribute to this international scientific event. And it was at the same time that the US was considering its plans of putting the first satellite into orbit. And so Eisenhower approved the US joining the IGY, specifically with the ideal of America launching the first satellite into orbit to circle the globe in between the years of 1957 and 1958. There was a very strong political reason for this, because the US was at a severe strategic disadvantage in terms of information in the mid-1950s. Thanks to the closed state of the Soviet Union and the Iron Curtain, as we call it, the US had a significant shortage of recent strategic information on Soviet military capacity, while the Soviets did not have that same disadvantage because of the more open society that the US enjoyed. And so the idea was that launching a scientific payload into orbit, which would be very clearly civilian-led, not associated with warfare, would contribute towards an open skies policy in which above a demarcation that could be labeled outer space, it would basically be free game to fly over whatever country that you wanted. And this would equalize the capacity of surveillance between small, medium, and large countries. Everyone would be able to look down on everyone else. And from that, a more stable political structure across the world would be achieved. And it wasn't just the US that was thinking about the strategic elements of spaceflight. The Soviet Union also said a week later that they would lead the world into orbit sometime in the near future. Now, this wasn't necessarily a pure competition between the US and USSR only. There were other actors in play as well. What is incredibly fascinating about this period of history is that the 1950s were a period of some of the most intense decolonization that you'll see in history. The number of sovereign nations internationally recognized increased from about 100 to 110 in the 1950s to 165 in the 1960s. So the number of sovereign nations in the world increased by 50%, effectively giving you one world of the US and its allies, a second world of the USSR and its allies, and then a new third world of unaligned potential allies or rivals that had come into being after the colonial powers' ability to control these colonies frayed after World War II. And it was seeking to impress these new potential allies that the USSR was able to achieve the world's first of putting a satellite into orbit. On October 4th, 1957, Sputnik 1 was launched on an R-7 missile into orbit. It was about 2 feet wide, no advanced scientific equipment. It was purely a radio transmitter. Its silver finish made it 6th magnitude to the eye, if you want to compare it to other astronomical objects. And it orbited the Earth for about 3 months. And it transmitted on the 20 and 40 megahertz radio frequencies, so people were able to hear it using their own radio receivers. Now, while the US civilian population was focused on Sputnik, Eisenhower was much more focused on the R-7 because it represented the Soviets being far more advanced in ICBM technology than expected. The US was able to respond to this achievement by launching our own first satellite called Explorer-1 on a Juno missile, which was technically a refurbished Jupiter missile. Explorer-1, while also very tiny, was significantly more advanced than Sputnik in terms of scientific payload. It included a cosmic ray detector. It included 5 temperature sensors, an acoustic detector. Even though there's no sound in space, the acoustic detector was built to detect micrometeorite impacts on Explorer-1's hull. And so with Sputnik 1 and Explorer-1 paving the way into orbit and proving that both nations had the capacity to launch payloads into orbit, there was a clear and present need for an organized effort in the US to manage space flight research. And so Eisenhower took a look at the different proposals for how to organize US spaceflight efforts and decided on focusing on a civilian-led agency. This would build from the foundation of the National Advisory Committee on Aeronautics, in which there were many experts already working on high-altitude flight or basic spaceflight, and wrapping the NACA with many different research laboratories and some military groups across the country. And this combined new agency would be the National Aeronautics and Space Administration, a force of about 8,000 personnel at its start that would communicate that the US wanted to explore space for civilian purposes and for peaceful purposes, and not specifically to weaponize it. There's a lot to discuss here about the militarization of space versus weaponization of space, and Eisenhower really wanted to avoid weapon connotations with space exploration. Now, with the successful early flights of uncrewed satellites, the next project was Project Astronaut, which was quickly renamed to Project Mercury, which many of us may be familiar with. And so Eisenhower worked with the first NASA administrator, T. Keith Glennon, and the deputy administrator, Hugh Dryden, Hugh Dryden himself being a giant of aviation, to work out what would be needed for the first group of people to be put into space. And these conversations were how the qualifications were decided. The astronaut had to be less than 40 years old. The astronaut had to be less than 5'11". This was dictated by the size of the Project Mercury capsule. And Eisenhower specifically wanted military test pilots for both information control and also because of the pre-existing experience if they had graduated from a test pilot school and held jet propulsion qualifications, knowing that these would be pilots that had the ability to adapt in incredibly dangerous situations. And this actually cut a significant amount of the military test pilots from the pool. I believe that America started with about 508 test pilots across all of the services. These qualifications, specifically because of the bachelor's degree and the jet propulsion qualifications, cut it down to about 100 service members. And that even then, a lot of pilots did not want to join Project Mercury because it was seen as a career ender. You weren't actually flying, you were just riding a capsule. But NASA went on a very strong advertising campaign and managed to convince about 50 applicants. And from them, the Mercury 7 were chosen. John Glenn, Deke Slayton, Scott Carpenter, Gus Grissom, Wally Schirra, Alan Shepard, and Gordo Cooper would lead the nation into space. Now, their training would take several years as they needed to get caught up on all the meanings and terms in spaceflight, as well as all the infrastructure needed to launch them was built and ready to be safe enough for a human to be put on top of it. And it was during this training process that there was an administration change. President Eisenhower stepped down and President John F. Kennedy stepped up with Vice President Lyndon B. Johnson. Now, Lyndon B. Johnson had a very keen eye for space. He saw it as the next frontier that it was for the international prestige payoffs that it could deliver. And so both of them took an eye towards filling the spot of NASA administrator. And this was incredibly difficult. 17 candidates declined one after another. NASA was seen as a boondoggle. Sure, you've been able to launch some satellites, but these astronauts haven't even been up in space yet, and yet we're treating them like royalty. All the costs are going up. No one wanted to be associated with it. And LBJ had the thought of someone that could potentially fill this job position. And this was a Democrat from the Truman administration, James Webb. He was the Undersecretary of State and head of the Bureau of the Budget, and had some basic engineering knowledge from being a pilot in the Marine Corps, but that was about it. He was walking into Lyndon B. Johnson's waiting room to discuss the job with the mentality of, I'm going to say no. Hugh Dryden is in that waiting room with him, and Webb just says plainly, I don't think I'm the right person for the job. I've never seen a rocket launch. I don't understand the engineering behind any of this. How am I supposed to lead it? And Hugh Dryden responded, I don't think you are either. And so Webb actually went into his job interview, affirmed in the decision that he would say no. But JFK and LBJ refused his refusal very strongly. Anytime James Webb started to talk to back out, he was talked back at. And eventually he acquiesced, saying that if the president, JFK, is so adamant at me taking the job, I'll take it. And it would be his experience as head of the Bureau of the Budget that would serve him well in the control of many of the programs that NASA was starting at the time. And while NASA was hoping to launch the first astronaut into space, fate would have that not be so. As on April 12th, 1961, the Soviet Union launched a cosmonaut on board the craft the Vostok 1 into a single orbit around the Earth. Launched from a site in present-day Kazakhstan, the Vostok 1 was launched into orbit, completing one orbit and then landing in the fields of the Soviet Union. And you can see a CGI model of the Vostok 1 here on the side. Vostok could not safely land, and so the cosmonaut would need to eject and land via parachute. And that cosmonaut coming down via parachute into the Soviet fields was Yuri Gagarin. Really seen as a symbol and a wonder child of the Soviet Union. He had worked in his youth as a foundryman at a steel plant, and then later joined the Soviet Air Force as a pilot, and from there was selected for the Soviet space program. This was a tremendous blow to US prestige across the world. The Soviets had beaten us not only to space, but to orbit. Gagarin had circled the Earth, and we did not have the same plans for our first flights. And this was only the start of JFK's very bad week, as only 5 days later was the failed Bay of Pigs invasion, the failed removal of Fidel Castro from Cuba. And so the US had lost a significant amount of international clout and prestige, and JFK was looking towards anything that could deliver a clear win and something that could unify the nation in a common goal. And so the following month, the announcement of the first American to go into space was made. This was Alan Shepard. He would fly on the Freedom 7 Mercury capsule on a mission called Mercury Redstone 3. This would not match Yuri Gagarin's feat. It would be a short 15-minute suborbital hop, 5 minutes up, 5 minutes in space, 5 minutes down to drop into the Atlantic Ocean and be recovered by the Navy. It was a stress-filled setup for the launch with many delays from a lack of will to commit Alan Shepard's life in this attempt. Shepard became irate at this because he was the one putting his life on the line. And he said, why don't you fix your little problem and light the scandal? And so in front of 45 million viewers on TV, NASA gave the go-ahead for the first American to fly into space.
Five, 4, 3, 2, 1. Liftoff.
That is Shepard's voice.
Liftoff, and the clock is started. Yes, sir. Reading you loud and clear.
Now, Shepard had a very smooth flight, even anticlimactically smooth, because the Mercury capsule was so small that he was effectively wearing the capsule, and he couldn't really enjoy the sensation of zero G. But Alan Shepard was successfully recovered from the Atlantic Ocean and became a nationwide hero. He was quickly flown to the White House for a special ceremony in which he received the Distinguished Service Medal from JFK. And you'll notice that you can see James Webb in the left of the frame here. NASA upper leadership were not allowed to leave. And so the next few days, JFK talked with NASA leadership about how to change the narrative of the space race. We were only just trying to catch up to the Soviets at this point, still not even matching them with only the suborbital hop. And Kennedy wanted a way to redefine the narrative in such a way that the Soviet lead could be minimized onto a scale that we could catch up. And so using notes that had been collected over the past 10 years from both civilian groups and the military, Webb and JFK worked out a potential new goal to fulfill by the end of the decade. And JFK would unveil this new plan in a special message to Congress on urgent national needs. This was a special speech that he had prepared for May 25th, 1961.
Space is open to us now, and our eagerness to share its meaning is not governed by the efforts of others. We go into space because whatever mankind must undertake, free men must fully share. I therefore ask the Congress, above and beyond the increases I have earlier requested for space activities, to provide the funds which are needed to meet the following national goals. First, I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space. And none will be so difficult.
And one of the things to take away from this video is that the members of Congress that you can see in the back of the frame aren't reacting terribly strongly. They are almost confused as to the proposition that we could land a person on the moon and bring them back a mere 3 weeks after we only had one suborbital hop. But over the next few days, Kennedy started to receive calls from members of Congress saying, well, what would actually be needed for this goal? We see the international prestige value. We also understand the amount of jobs that such a public works program would create. And so NASA was given the go-ahead to form the Apollo program. Apollo would be designed and built to bring 3 astronauts from the surface of the Earth into lunar orbit. 2 of those astronauts would then land on the moon, come back up, reunite with the 3rd, and return back to the Earth. And the Apollo program was named by NASA manager Abe Silverstein, specifically because of the iconic imagery of Apollo and his golden chariot soaring across the stars. But the mission mode of bringing astronauts to the surface of the moon was a source of contentious debate for several years. Many people wanted the plan of direct descent, in which one massive vehicle landed on the moon and then took off again. But John Hubalt from Langley argued that a more complicated program called Lunar Orbit Rendezvous would be the best way to go about this. One giant craft landing on the moon would be absolutely massive because you're bringing all of your gear down this gravitational potential well and bringing much of it back up again. If you have a small dedicated craft, you would save a significant amount of mass. And this ended up winning over the minds of NASA higher ups, with rocket scientist Wernher von Braun being the last to sign off on it. He had preferred Earth orbit rendezvous because of its potential application for space stations. But of course, his life story is another presentation. Now, with this design mode it chose of lunar orbit rendezvous, NASA could begin work on the infrastructure needed to bring astronauts to the moon. Unfortunately, our leader would not be able to see it to fruition, as on November 22nd, 1963, John F. Kennedy was fatally shot by Lee Harvey Oswald during a goodwill trip to the South, as part of not only to get the 1964 election cycle moving, but also to smooth over some differences between Republicans and Democrats in the South, as well as Northern and Southern Democrats. After his assassination, Lyndon B. Johnson was very quickly sworn in as president, and he took a very protective view of Apollo. Not only had he really championed spaceflight since his days as Senate Majority Leader in the 1950s, because of all of its uses for the nation, he now was able to tie this into a "don't you dare touch this, we need to fulfill this goal for our fallen leader." But it would still be many years out. The infrastructure that NASA needed, not only to build the rockets to send humans beyond Earth orbit, but the buildings to build such vehicles were still not done. They would be many years out, and the largest of which, the NASA Vehicle Assembly Building here, would only finish construction 4 years later. So there was still many years to go before the physical items that we need to go to the moon would be constructed. And therefore, we could spend that time learning all we could learn for our astronauts to have our best chance of completing Kennedy's goal. And so Project Gemini was born, named for the constellation Gemini of twins. This would be a program to send 2 astronauts into space, into orbit, to answer many critical questions needed to send astronauts to the moon. This would include having to change orbit mid-flight, how to rendezvous 2 craft, bringing 2 craft very close together. Once they are close together, how do they dock and combine into one craft? If astronauts go to the moon, well, they're not just going to sit around in their craft. We want them to do work on the surface. And so how can astronauts work outside of the spacecraft? And finally, how long could astronauts work in space? Gemini is easily one of the most interesting programs, in my opinion, because it was such a rush to answer all of these questions in ascending complexity. And Gemini would fly 10 crewed flights over only 2 years. On average, Gemini flights were going up about every 6 weeks, from 1963 to 1966 about. And some of the critical turning points of the space race occurred in Gemini. On December 15th, 1965, Gemini 6 and Gemini 7 met in orbit. So the Gemini spacecraft were significantly more advanced than the Mercury capsules that the Mercury 7 had written. These were crafts that had 2 astronauts in them and maneuvering thrusters that could be used to change the orbit of these craft, fulfilling that first goal, and then bringing them close enough together to rendezvous, which is what you see here. 6 and 7 were able to fly with precision accuracy within 0.3 meters of each other while flying 17,500 miles an hour in orbit around the Earth. And these images from the rendezvous of 6 and 7 really communicate the turning of the space race. The Soviet Union had launched concurrent missions before, for example, Vostok 3 and 4, but they had been launched separately and could not change their orbits, and so were only in radio contact with each other, kilometers away from each other. This mere feet from each other achievement really proved that America had the ability to learn and do something new in space. Now, it wasn't all these precision flying test flights throughout Gemini. There were some experiments that were done. And at the end of the Gemini program on Gemini 12, the first photo of a solar eclipse from space was photographed on November 12th, 1966. This was Gemini 12, the crew of Jim Lovell and Buzz Aldrin that you can see here on the bottom, with Buzz being on the left and Jim being on the right. And they were able to photograph the eclipse using Kodak Ektachrome film, but only in black and white. And I believe a master of this still exists somewhere in the Smithsonian archives. Now, with the tremendous success of Gemini and learning how to perform precision maneuvers, how to rendezvous crafts together and dock them, as was done on Gemini 8, we could finally move on to Apollo. And Apollo would be a tremendous upgrade in terms of space. After all, we would be sending many experiments with the astronauts to the surface of the moon. To give some perspective on how the vehicles changed with time, we have the Mercury capsule, which only sent a single astronaut into both suborbital and later orbital flight. There was 1.7 cubic meters of space for that crew member. If you imagine being in the front seat of your car and cranking it way forward so that you're right up against the wheel, the steering wheel and all the dials, that maybe gives you an indication of how cramped Mercury was. Gemini, for all of its maneuverability upgrades, gave 50% of the extra volume for twice the amount of astronaut. And the Gemini capsules were used on missions for as long as 2 weeks. So they were very stressful times for some of those astronaut pairs. But Apollo was downright luxurious in comparison, with about 6 cubic meters for the 3 crew, in which their seats holding the crew would be suspended in the middle of the capsule, and you would have a wide open space in the back to store experiments and lunar samples. Now, because of the debate over the landing mode for Apollo between direct descent and lunar orbit rendezvous, we actually had several capsules that were already built for direct descent and so lacked an airlock in the front. These would be called Block 1s and used for test flights. And astronauts had significant concerns about these old Block 1s, because how can you truly say that this is a valid test flight if we're not flying the right type of vehicle? The lunar module that would bring astronauts to the surface, which was a separate craft, also underwent significant revisions during this design process from 1963 to 1966. Many of the initial concepts included huge windows, which would be made of transparent material that would be far, far heavier than could be allowed on these missions, and so the windows were downsized. The craft was built such that it was one combined stack. Here we go. One combined stack made of 2 pieces. The bottom piece was your descent stage and had the engine for slowing down so you could softly land on the lunar surface, and would double as a launch pad for the upper stage, which would have its own engine and bring the 2 astronauts back up to join the command module mothership in lunar orbit. Now, these 2 craft would themselves be flown simultaneously by the Saturn series of rockets. So the Saturn I was actually first flown in 1961, very early in the space race, and was the first rocket designed for non-weaponized use. So all the previous capsules I had mentioned, Mercury and Gemini, had flown on converted missiles, whether it be the Redstone or the Atlas or the Titan ICBM. Saturn was built from the get-go to be a cargo mover, moving high-weight satellites into orbit. And the Saturn I would be continuously updated into the Saturn 1B that could put 46,000 pounds into orbit. And the lunar lander and the command module would be in the top stage that you can see here at the top of the rocket. If you're unfamiliar with how the stack works, here is a cutaway view. The lunar module is actually in this shroud underneath the command and service module. The command module is where the astronauts would be during their flight. And then once in space, the command module would swing around, dock with the lunar module, and extricate this combined from the Saturn upper stage, which would then fly on its merry way into deep space. But the Saturn I wasn't enough to send all of this weight to the moon. And so an absolute behemoth of a rocket was developed called the Saturn V. This would use the then experimental liquid hydrogen and liquid oxygen for its upper two stages for maximum efficiency. And then its bottom stage would be a symbol of pure power. It would use RP1, a special form of kerosene, and liquid oxygen for its pure power instead of efficiency. And those would be funneled through 5 F1 engines designed by rocket scientist Wernher von Braun. To give you some perspective in why I'm hyping up these engines, a single F1 engine gave more force than the entire lower stage of a Saturn 1B. There's that much of an escalation of power by adding this lower stage and creating the Saturn V. And while we were so close to being able to put the first human beings onto this rocket series, tragedy struck NASA.
Special report. This is Mike Wallace at the CBS Newsroom in New York. America's first 3 Apollo astronauts were trapped and killed by a flash fire that swept their moonship early tonight during a launch pad test at Cape Kennedy in Florida. Virgil Gus Grissom, 40 years old, one of the original Mercury astronauts, the first American astronaut to go twice into space. Edward White, 36 years old, the first American to walk in space. And rookie astronaut Roger Chaffee, 31 years old, training for his first space flight, Apollo 1, scheduled for February 21st. These 3 astronauts were aboard their spaceship 10 minutes from a simulated liftoff at Cape Kennedy when the fire hit at about 6:30 tonight. They were inside their spaceship, pressurized, buttoned up inside their spacesuits when the fire hit. A closed-circuit television camera was relaying pictures of the astronauts lying on their backs inside the spacecraft atop the 2-stage Saturn I. There was a flash, and that was it, according to a NASA spokesman watching the television screen in the blockhouse a few hundred yards away from launch pad.
And so this would be known as the Apollo 1 fire. The crew of the first Apollo mission planned, Gus Grissom, Ed White, and Roger Chaffee, all died incredibly quickly due to asphyxiation when a fire broke out in their capsule during a test. This occurred and was so tremendously lethal because while on the pad, the capsule was pressurized to 16.7 pounds per square inch of pure oxygen. This was done to mimic the pressure differential the hull would feel while in space. In space, the capsule would be pressurized to 5.5 pounds per square inch. And that pressurization level was known to be safe for fire control. The astronauts could address it. But at 16 pounds per square inch of pure oxygen on the ground, it was immediately a flash fire after an errant wire spark. And the fire burned through the hoses of their life support systems, and they died of carbon monoxide poisoning. This led to a massive restructuring of procedures for testing, as well as a revamp of the Apollo command module. And in honor of their sacrifice during these tests, their mission was formally known as Apollo 1, and many test flights that were occurring at this time were given retroactive designations, such as Apollo 2 and Apollo 3, which were uncrewed test flights. It would take 22 months from the close of the Gemini missions to the first of the crewed Apollo missions, after all of the safety design changes were made to the Apollo capsule, such as a door that was easier to open in an emergency, as well as a mixed oxygen and nitrogen atmosphere whenever you were at that critical 16 pounds per square inch pressurization level. And so on October 11th, 1968, with barely more than a year left in Kennedy's deadline, we were able to launch the first crew as part of the Apollo program on Apollo 7. This was purely a test of the new Block 2 Apollo capsule. Pretty much the main problems that this crew encountered were motion sickness and head colds that created significant tension between mission controllers and the crew. But they were brought back safely, proving that the Block 2 could do its job. Due to the success of Apollo 7 and the looming deadline of the end of the decade coming up, NASA gave the go-ahead for something tremendous, an ambitious flight to fly by the moon and quickly return to the Earth, known as Apollo 8. This would be the first crewed flight of a Saturn V and would be a quick 6-day jaunt to go to the moon and immediately fly back to Earth. While circling the moon, they made one of the most watched TV broadcasts ever and read from the book of Genesis on Christmas Eve, which won them a special Emmy. And circling back from the other side of the moon, they found something that no one was really expecting. Everyone knew the concept that we would be able to see the Earth from a new vantage point while in space. However, this photo taken by the crew of Apollo 8 with the Hasselblad still camera fitted with a 250 millimeter telephoto lens is known as either the Earthrise photo or the discovery of Earth, and would be used as an environmental symbol by many for decades to come, showing just how small and fragile of a planet we all cohabitate together. Apollo 8 came back to Earth heroes for being the first human beings to circle another astronomical body. And so with that success, we were able to start testing the lunar lander. This module was tested first in Earth orbit. This was an incredibly dangerous mission when you think about it, because you have James McDivitt and Rusty Schweickart in the lunar module here in Earth orbit, separated from the command module. And this is the first time that human beings flew a craft that could not safely re-enter Earth's atmosphere. Fortunately, everything went well, clearing the lunar module for future flights. Up next would be the dress rehearsal, practicing everything that we have learned up until now with the command module and lunar module procedures. And this was Apollo 10. All veteran astronauts, Gene Cernan from Gemini 9, John Young from Gemini's 3 and 10, and Tom Stafford from Gemini's 6 and 9, were given the go-ahead to actually bring the lunar module down close to the lunar surface. They were purposefully only given enough fuel to make a partial attempt at the landing, and they came within 8 nautical miles, or about 15 kilometers, of the lunar surface. With that success, they came back up to the command module and safely returned to the Earth. And so the stage is set, the dress rehearsal was a success. We have learned everything we have to learn, and we still have only about half a year left to complete Kennedy's goal of landing astronauts on the moon and bringing them safely to the Earth. And so coming up next is Apollo 11, a time of momentous historical significance for the world. And even its mission patch, which I've pictured here, is built to commemorate that historic nature. The astronauts voted to exclude all names from this patch. Normally, when you look at mission patches, you see the astronauts' names. This one has no names, specifically to communicate that this was for everyone. And in thanks to so many people who had worked together as part of this program. Additionally, as a symbol of accessibility, the traditional Roman numerals were substituted for traditional Arabic numerals of 11 that you can see here to make it easier to read for any cultures that may not have experience with Roman numerals. And the astronauts that would be flying to the surface, to the lunar orbit, and then some of them to the surface of the moon, would be Michael Collins. It would be his job to manage the command module in orbit of the moon. And Buzz Aldrin and Neil Armstrong would pilot the lunar module down to the surface of the moon. And so on July 16th, 1969, human beings left Earth to set foot on another world.
20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11. Tower cleared.
We got a roll program. Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on proper
And with this
heading.
successful launch, Apollo 11 began their 3-day trip to the moon, entering lunar orbit on July 19th of 1969. The following day, Buzz Aldrin and Neil Armstrong crawled into the lunar module to begin their descent to the lunar surface. This was a fraught descent. Buzz Aldrin kept the rendezvous radar and the landing radar on at the same time, stressing the amount of RAM that the lander had, but they were able to power through it with the computer smartly managing the memory of the craft as they came in for a descent. However, Armstrong noted that their original landing site had a prodigious amount of boulders, and so he needed to translate the module to the side and find a new suitable landing site, eventually consuming much of the fuel that had been planned. Here I'm going to show a video of that landing process, and this bingo call that you see mentioned in the side of the video, that is the "you have to abort because you don't have enough fuel to get back up into lunar orbit." And so it is effectively a time limit for Armstrong to safely land on the surface.
That's 40 feet down, 2.5, picking up some dust. 30 feet, 2.5 down, straight shadow, 4 forward, 4 forward, drift into the right a little, 20, down a half, 30 seconds forward, just, good. Okay. Contact light. Okay, engine stop, ACA at a descent. Mode control both auto, descent engine command override off. Engine arm off. 413 is in. We copy you down, Eagle. Listen, Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing
So
again.
Armstrong's mention of Tranquility Base was an ad lib. That's why the communicator was not familiar with that call. But with the words of contact light being the first spoken by a human being in direct contact with another world, the Eagle had landed safely in the Sea of Tranquility. Armstrong would exit out of the lunar module and place himself in the landing gear, effectively, of the lunar module. There were these big pads that were used to cushion the lunar module against the lunar soil. And so standing in that pad, Armstrong made the first step onto the lunar surface.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
And so with that statement, one small step for a man, one giant leap for mankind, human beings were now able to walk and work on the surface of the moon. Now, this was a very short Apollo visit. Armstrong and Aldrin only spent about 2.5 hours outside of the lunar module and took off after their landing only 21 hours later. And so on July 21st, Armstrong and Aldrin joined Collins up in the command module, and both returned to Earth safely, becoming international heroes, starting a 37-day journey around the world, visiting countries everywhere, Mexico, Yugoslavia, Zaire, being seen by over 100 million people, communicating the value of spaceflight and the shared achievement of humanity. Future Apollo flights would happen at a slower cadence now that we had met Kennedy's goal of doing this by 1970. Apollo 12, while it had some issues during launch by being struck by lightning, would be just like Apollo 1. However, I joked that it's twice the work because they had 4 hours of extravehicular activity on the surface, placing passive solar wind experiments away from the lunar module. They even had a passive Apollo lunar surface experiment package, which needed a plutonium fuel element, which was quite difficult for them to actually install, and they needed to use a hammer to hammer the plutonium fuel element into place. But it ended up working and everyone was safe. And Apollo 12 was also one of the most precise landings, landing next to the Surveyor 3 probe, which is the first time that humanity had actually went and reunited with one of our automated craft out in space. The next mission would not be as smooth. This was the tale of Apollo 13. This is worth an entire talk on its own, so I'll just quickly say that due to an oxygen tank being dropped 2 inches during manufacturing, one of the oxygen tanks in the service module exploded most of the way to the moon, and the Apollo 13 astronauts were able to use the lunar module as a lifeboat to return to the Earth safely. Apollo 14 would do their best to replicate the Apollo 13 mission in the good ways by landing in the Framora Highlands and landing near Cone Crater, which was known as a young formation. They placed a series of seismometers and mortars that, once they left the lunar surface, would be used to fire these mortars to trigger shock waves for the seismometers to understand the internal structure of the moon. However, this was even then a smaller scale mission than the last Apollo missions. Apollo 15 was the first mission to include a lunar rover, and was an incredibly longer mission with 18 hours of extravehicular activity, and a rover enabling them to go 17 miles across the surface of the Hadley Rill to collect samples. Now, it wasn't just David Scott and James Irwin on the surface having scientific fun. Al Worden was in orbit, actually deploying a mini satellite to test the magnetic field and gravitational field of the moon. The second to last Apollo mission was a 3-day long mission on the surface, and they were able to recover the largest of the lunar samples, called Big Muley, being named after one of their program managers, which was 26 pounds in total. But it wasn't just geology, and this is one of the last experiments I'm going to share with you. You can see behind the astronaut here, there is a device. And some of you may be happy to know this was a telescope. It was the Far Ultraviolet Camera and Spectroscope, designed by Dr. George R. Carruthers of the Naval Research Laboratory. It was built to observe UV observations of the Earth. It could take spectra from 300 to 1,300 angstroms, and images in 2 different pass bands at about 1,000 angstroms and 12 to 1,500 angstroms. And the image that I included here is an image of one of the oxygen transition lines in the UV of the Earth. So you're seeing oxygen transitions in the UV from the Earth's atmosphere in that photo. I tried looking up the specific transition for you, but I couldn't find it in time. Sorry about that. And with this astronomical trip, Apollo 17 closed out the Apollo program with a significantly more geological focused mission with Harrison Schmitt, who was previously a worker at the US Geological Survey's Geology Center in Flagstaff, becoming an astronaut thanks to his jet experience, and becoming the first scientist on the moon. From both Gene Cernan and Harrison Schmitt's spacewalks, we were able to find orange volcanic rock in Shorty Crater on the moon. Everyone was very excited about this, thinking that it pointed to much more recent volcanic activity on the moon, but it turned out that it was billions of years old and had only been unearthed because the crater was about 15 million years old and had unearthed this old material. And so with the conclusion of Apollo 17, the astronauts left behind a plaque. Here, man completes his first explorations of the moon, December 1972. May the spirit of peace in which we came be reflected in the lives of all mankind. The astronauts took off from the surface on December 14th, returning to Earth on the 19th. And this would remain as the farthest humanity would explore in person to the present day. So the Apollo program had successfully landed 12 astronauts on the near side of the moon and met President Kennedy's objective. 6 Apollo missions had collected about 2,200 samples of material, weighing in total 380 kilograms or about 840 pounds. And these were samples that were split up into over 100,000 individually cataloged samples that were shared with much of the world for their scientific value. And so here we come to the end of the Apollo program and remember all of the tremendous feats that were possible thanks to the nation deciding to make such a tremendous commitment of resources. In today's money, the total lunar effort would total about $280 billion. So this was a tremendous investment on the part of the American taxpayer, and is one that will be remembered for all time. So thank you all very much for joining us. If you would like to know more, here's a selection of the books that I used to base much of this material on. And thank you very much for having me.
All right, fantastic talk, Kevin. Thank you so much for coming in today. Yeah, this is, one of those pieces of information that, many of us will hear a little bit about in, our high school years, but there's so much more to it than that. And as you mentioned in your talks, this is only a small part of what is honestly a much larger series of talks, which I know you have been doing at the University of Kansas.
Yes, thank you for allowing me to get an advertisement in there. So this is part of a month-long series that I've been giving at KU. So it's split up into 4 episodes. The first 3 are already uploaded onto the KU Public Talks YouTube channel. The first one being pre-NASA spaceflight history. I have an entire hour's worth of material talking about that. And then Projects of Mercury, Gemini. And now you got to see the Apollo content before anyone else, before I recorded the formal version of that. So you got a preview of some of the content to come.
Right. So at this point, we do still have a few more minutes before 1 o'clock. So if anyone has some questions, please feel free to unmute yourselves.
Good question.
We have a question from Jay in the chat. Yeah, how did they fit the rover into the Apollo capsule? Or from another point of view, was there a lot of empty space in Apollo 11?
So I'll answer the first question first. How did they fit the rover into the Apollo capsule? Well, they didn't fit the rover into the capsule itself. When I described the lunar module, I had described 2 different stages: the ascent stage that would bring the astronauts back up to the command module, the mothership. And then there was the lower landing stage that would include the engine to slow them down to bring them to the surface. By the time of those later missions, the lunar module had been perfected enough to allow for a hatch to be built in the side of that bottom stage that would fold out, and then they could bring the rover out of that and unfold it on the lunar surface. So rather than being in any of the capsules, it was part of the service component of the lunar module. So $280 billion, including Mercury, Gemini, and Apollo. Okay, so there is a great write-up by Casey Dreyer of the Planetary Society, if you want to get into like the real nuts and bolts of it. But Mercury and Gemini were each comparatively very cheap, about in the single digits of billions each, whereas Apollo was in the several hundred billion when you account for inflation, thanks to just the amount of infrastructure that needed to be built for the Saturn series, all of the money that needed to be poured into the redesign of the Apollo command module, and then the lander, which had many delays that I couldn't talk about here. So Mercury and Gemini, you can include it in the 280. That was a rounded value because they are much smaller with respect to the Apollo expenditures. Yeah, so I'm seeing, thank you very much for the positive feedback. Apollo flew to moon. Yes, I've heard good things about that. From the Earth to the Moon mini series is good. There is the series that was inspired by A Man on the Moon, which is one of the books that I had suggested here, that is now on HBO as well. That's very good. It's very common for people to play the lunar module construction episode to inspire people to go into engineering careers. It's just that good. I think it's titled Spider. So if you have HBO, you should go watch that. It's amazing. And yeah, I think that there's so many things that can be discussed here. So if you're interested, please look at the other talks. I also have plenty of book recommendations as well.
So Kevin, I realize this is moving a little ahead of things, but to your knowledge, what was it that led to the end of the lunar missions with the last Apollo?
So the cancellation, I didn't have room to talk about Nixon in here, but the cancellation of the Apollo program actually happened after Apollo 12. It was very, very, very early. Each Saturn V was about $2.2 billion in 2010 dollars. I need to correct that knowledge now. So it was extremely expensive. We had already beat the Soviets. The Soviets had made it clear that they weren't willing or able to compete with the failure of their own rockets called the N-1 that would have brought Alexei Leonov to the moon. He would have been the first Soviet moonwalker if it had worked. And so at that time, there was also a significant split in attitudes and priorities in the American public. Apollo only had like a 50% approval rating during the first lunar landing. This was a period of tremendous strife. If you think about Vietnam and the civil rights movement, 1968 also had a significant amount of assassinations at the time. So there was definitely a feeling of Apollo was a good escape, and we were able to complete our objectives in securing American leadership in exploring another astronomical body. But with the completion of that, there was a significant drop off of interest, even though the later Apollo missions grew in incredible complexity, going from 2 hours of an EVA on Apollo 11 to about 18 hours, I think, on the final one, conducting geological experiments across miles. And so it's kind of a shame that it was canceled when it was, because there were even plans for lunar landing on the far side of the moon, which would have been incredibly dangerous and also educational because of how little was known over there at that time. And because of this turning away from the lunar landings, many people looked for ways for Apollo tech and infrastructure to be saved. This was the Apollo Applications Program. We see its successes in the Skylab program, America's first space station, as well as the diplomatic mission of the Apollo-Soyuz joint project in 1975, where we had cosmonauts and US astronauts flying together in peace in the middle of the 1970s. It's amazing. But because of all the costs associated with Apollo and the generation of Saturn Vs, everyone was looking towards something that was cheap and reusable. And so the proposals on the wall for the space shuttle attracted all the attention. That's where we went. Space shuttle itself is worth many courses on its inability to deliver on that cost reduction. But the shuttle did have many amazing things that it did, such as Hubble, that we enjoy to the present day. So there were many points of pressure on why Apollo was canceled when it was.
Thank you. Okay, so it's 1 o'clock now, but if anyone has one final question they'd like to ask Kevin, by all means. But if not, you can always get in touch with him or tune in to his past and future KU talks. Thank you again, Will, for adding a link to that in the chat. And I guess I would like to thank you very much for coming here today virtually and sharing all of this information, celebrating 52 years now since we've first landed on the moon.
Yeah, thank you so much for the invitation. It was a blast. Thank you all very much.
All right, take care, everybody. And remember, next week we have another Science Lunch Talk, this time with our NRAO's very own Bang Nan. So I hope to see you there. Take care, everyone.